One of the seemingly simple questions that opens up stories about geology, chemistry, and even the evolutionary history of the Earth is, why is the sea salty? To answer this question, we need to explore many aspects, from the origin of seawater, natural chemical mechanisms to the formation and development of the planet over billions of years. Before we get into why the ocean is salty, let's look at what seawater is. Seawater is more than just water. In fact, every liter of seawater contains about 35 grams of salt and dissolved minerals, forming a complex solution containing sodium chloride NaCl. This is the main ingredient, accounting for about 85% of the salt in seawater, which gives it its characteristic salty taste. Magnesium, calcium, potassium, and other ions. These minerals are present in lower concentrations, but still play an important role in maintaining the chemical balance of seawater. Seawater also contains trace metals, organic and inorganic compounds, and even dissolved gases such as oxygen and carbon dioxide. The presence of these components not only shapes the characteristics of seawater, but also reflects long-standing geological and biological processes on Earth. As you know, 2/3 of our Earth's surface is covered with water, of which 97% is salty seawater. Only 3% of the water on our Earth is fresh water, and 2% is frozen or deep underground. Why is seawater salty? The reason why seawater is so salty that we cannot use it for domestic purposes is because the salt content in seawater is very high, combined with minerals and compounds such as potassium nitrate and bicarbonate, which account for 85% of the dissolved solids. It is estimated that about 3.5% of the world's oceans contain sodium chloride, which translates to 50 quadrillion tons of salt. And if you spread that amount of salt across land, it would be 152 meters thick. Salt has been accumulated in the oceans in various forms for billions of years. There is a hypothesis that the salinity of seawater is pre-existing, and that this amount of salt will not change if calculated according to the age of the Earth. The increase or decrease of salt content is not fixed over time. Furthermore, the salinity of seawater in different locations on Earth is not the same. For example, in the polar regions, seawater is not as salty as other places because it is diluted by the melting ice there. In tropical regions around the equator, increased heat causes a large amount of water to evaporate, and when it rains, it makes the sea water saltier. The first reason why salt appears in seawater is due to the amount of salt produced from rocks, from sediment layers deep under the sea. When rainwater falls and dissolves minerals, the salt from the rocks flows into the river. The amount of salt accumulated in large and small rivers gradually flows into the oceans through estuaries. Over a long period of time, the salt gradually settles, making the sea water salty. Volcanoes active both on land and under the ocean contain minerals, salts, and seawater. Other salts are lost from lava that erupts from volcanoes and are buried deep in the layers of rivers. Magma from volcanoes at the bottom of the ocean rises up and heats the water in this area. At the same time, the rocks and lava from volcanic eruptions settle on the seabed and are dissolved. Ocean ridges have hydrothermal vents with very high temperatures that melt the rocks under the ocean crust, containing a lot of salt and minerals in them. One hypothesis is that the salts came from eroded soil layers or from lava flows from rivers. In fact, most of the salt in the oceans comes from land. When rain falls, the salt and minerals in rocks and dry soil dissolve and flow into rivers. River water carries dissolved minerals downstream in the form of solution. Although the amount of salt is quite small, it accumulates gradually over time and flows into estuaries leading to the ocean, making seawater here. It can be seen that the amount of salt increased annually from the rivers will be equal to the amount of salt accumulated at the bottom of the sea. According to researchers, measuring the salinity or concentration of some special components such as magnesium, NaCl, sodium, the salinity of seawater changes according to minerals, and the variation of sea level depends on many different factors such as the level of ice melting, the amount of water flowing into the sea, the level of evaporation, wave movement, movement of ocean currents are important factors. In fact, the Atlantic Ocean is the saltiest ocean with an average salinity of about 37.9 because the temperature in this area is quite high and it is located quite far from the mainland, so it does not receive any fresh water from rivers and streams to neutralize the saltiness of this ocean.